calculating each of these limits is going to be a fair amount of work. And there's different tricks for each one. Let's look at the first one. And in the first one, so that's not working. Example H. In this first one, part of the problem that you're going to face is figuring out what 6 plus h cubed is. Now, please do not tell me that that's 6 cubed plus h cubed. If you did that, let me just say that your paper would be very easy for me to grade, all right? Now, one way to expand this is to do 6 plus h times 6 plus h times 6 plus h. I'd be really unhappy doing that. Very unhappy. So let me remind you of something called Pascal's triangle. And even though he didn't invent it, he got his name attached to it. You might also want to, for giggles, look up something called Pascal's wager. In any case, it starts out with a 1, and then a 1 and a 1. You keep on putting 1s on the outside, but on the inside, you're going to add these 2 going down. So it'd be 1, 2, and then 1. And then the next one, put 1s on the outside. What am I going to have on the inside? 3, 3. And that's good enough for our purposes here. I'm not going to be mean to give you something a little bit higher than that. But what does that reflect? These are going to be the coefficients that you get if you expand, for instance, a plus b to the 0 power, that would equal 1. A plus b to the first power would be a plus b. So these coefficients are right here. A plus b squared, a lot of you do that in your head, a squared plus 2ab plus b squared. Let me put in some coefficients here for you, 1, 2, and 1. And finally, the last one is a plus b cubed, and that's going to be, well, let's pick up these columns, or this row here. You're going to start out with this thing to this power, a cubed, and then decrease the power of a squared b, and then decrease the power of a again, and increase the power of b, and finally increase the power of b one more time. A to the 0 we don't need to write, but the coefficients are these numbers from Pascal's triangle. 1, 3, 3, and 1. Obviously you don't need to write the 1s, but I'll just put them there to make clear what the pattern is. All of that lengthy explanation is just to help you expand polynomials like this, or binomials like this, I should say. So let's do that. It's going to be 6 plus h cubed. In this case, my a is 6. So it's going to be 6 cubed plus, and leave a little space here, then it's going to be 6 squared times h plus 6 times h squared plus h cubed. Now let's not forget our coefficients from Pascal's triangle. So it's going to be 1, 3, 3, and 1, which I'm not going to write. Well, I'll write there. 6 cubed is 216. 3 times 36 is 108. No, is that right? Yeah, 108. 108 h plus 18 h squared plus h cubed. So, wow, a long ways to go to get this. But if you're going to do this one algebraically, this is the kind of work that you would benefit from. I mean, look, you could multiply it out a term at a time, you know, this times this, and then distribute this. It'll work, but I hope that you use kind of a smarter way to do that. Let's actually look at the limit now. Now that we know what this looks like expanded, let's calculate the limit itself. So it's going to be the limit as h approaches 0 of 6 plus h cubed minus 216 over h. The problem we were having with this one is that when you tried to plug in a limit, we ended up with a 0 over 0, and that wasn't really good. So let's expand this now that we know what that is, and that's going to be the same thing as the limit as h approaches 0 of 216 plus 108h plus 18h squared plus h cubed minus 216 over h. Whew, a lot of work to get here so far. Are we okay with where we're at? What can I do now? I can't cancel the h in the bottom yet, but I will in a minute. But I got to do something first.
216.
Yeah, let's get rid of the 216s, right? You have plus 216 and a minus 216. That gives you a 0 between those two. But we still have some other terms left. It's limit as h approaches 0 of 108h plus 18h squared plus h cubed over h. Please don't cancel this h into this one. You can't do that. What do I have to do instead? Somebody's just said it.
Factor in h.
Factor out an h. So if you factor out the h, that leaves behind 108 plus 18h plus h squared divided by h. Okay, looking good. Bless you. Now we can cancel the h. And that will give me the limit as h approaches 0 of 108 plus 18h plus h squared. Ugh. That's not looking much better, is it? Or is it? What do you think? It is? Okay. What should I do now? Actually, I don't want to factor it. A little bit less work than that. Sasha? We already got the h. Yeah, plug in the limit, right? I mean, it's the problem that we were having up till now, until right this step, is that when you plugged in h, you got 0 over 0. But now that we've canceled that, that problem's gone. Now you can just plug in the limit. Max, what do we get when we plug in the limit?
108.
Yeah, it's 108 plus 18 times 0 plus 0 squared. It's just 108. Nice. Very nice. How could you confirm that if you're looking at that going, yeah, I don't know, I don't believe that. That just looks weird. How could you confirm that?
Table.
Yeah, graph, table. So let's try it quickly with a table. So I'm assuming that everyone's table is still set up like this. Independent set to ask, dependent set to auto. Let's plug in our function. Double sets of parentheses in the numerator so that we have 6 plus, we're going to use an x as opposed to h. And that extra set of parentheses in the numerator is to close off the entire numerator. So that closes off the numerator divided by, we're using x instead of h. And now let's go to our table, second graph. And this looks like it's set up pretty nice. Notice you got some values of x coming in from the left and some values of x coming in from the right of 0. And both of them are centering on 108. Now, that's a little deceiving. It looks like it says 108, but it's not probably actually exactly 108. There's probably some digits that are hidden here. So if you actually put the cursor on that 108, at the bottom it will show you the actual value. So there you go, 107.9982. That's pretty close. All right, so it's pretty close to 108. Safe bet that it looks like it's heading to 108. You could also look at it graphically and reach the same conclusion. Okay, so we okay with that first one there? All right, let's try the second one. And like I said, each of these has its own trick, which is why I'm going over all 4 of them. Let's see. So the next one, another trick that I want to remind you of is this. So let's do reminder. A minus b times a plus b. When you multiply a binomial like a minus b times a plus b, these things are called conjugates. So multiplying by the conjugate is a trick that we're going to use. Let's understand why. Does anyone know what happens when I multiply these two together? What do I get? You get a squared, you get a plus ab, minus ab, minus b squared, but you get a little simplification along the way. What's that simplification along the way? Those cancel. You're just left with a squared minus b squared. And that's kind of handy. So it's a way to get rid of these cross product terms and just end up with the square of these other terms. So that's the little trick that we're going to use here. Let's bring it down now to the limit as h approaches 0 of the square root of 9 plus h minus 3 over h. Ethan, I think you know your role at this point. What should we try first?
Plug in the limit.
Yeah, plug in the limit, 0. And when we plug in the limit of 0, Lillian, what happens to this quotient if I plug in an h equals 0?
You're not equal to it?
Why not?
You can't do like, wait, never mind.
So if I plug in a 0, that'd be 9 plus 0 would be 9.
0 over
So, yeah, square root of 9 is 3, 3 minus 3 is 0. You end up with 0 over 0. When you end up with 0 over 0, the problem is screaming out to you. You've got to do something different, all right? You're not going to be able to evaluate this directly just yet. So our trick is to multiply by 1. That's the only thing we can do. This isn't an equation. You can't multiply both sides by h and get rid of the h because it's an equation. No, it's not an equation. So the question is, what form of 1 are we going to choose? So let's take a look at that. Limit as h approaches 0, square root of 9 plus h minus 3 over h times, and let's do this. Let's put in some parentheses. I got to multiply by something. What form of 1 should I choose? Well, it has to be something over itself so that I'm actually multiplying by 1. And if you're a good student of movies and books, you might notice that a lot of times they do a little foreshadowing. And your instructor did a little foreshadowing here too. About as subtle as a brick. I gave you this little reminder here. Now I see a little something minus something here. So the conjugate would be that something plus something. It would be square root of 9 plus h plus 3 over square root of 9 plus h plus 3. So you're multiplying by the conjugate of the numerator. Limit as h approaches 0. Now, some people might call it laziness. I call it economy of movement. I don't really want to FOIL this out. I don't want to do this times this, and this times this, this times this, this times this. I know the exact pattern of what happens here. When I multiply conjugates, I'm going to get a squared minus b squared. So let's see what that's going to equal here. This is my a. What do I get when I square that?
9
9 plus h, right? Square root of something squared. What do I get when I square this? 3 squared is, come on, without your graphing calculator, 9. All right. Now in the denominator, well, again, I'm going to be a little bit circumspect about doing this. I'm not going to distribute the h. I'm going to keep it factored out. I'm anticipating something that I can kind of see on the horizon when I look at this problem. If you try to plug in h equals 0, you'd still have a problem. You'd still end up with 0 over 0, and that's not going to work. But we're a lot closer to a solution here than we were just a minute ago. What can we do? Cancel the 9s. All right, so cancel the 9s. And then what else? We're left with limit as h approaches 0. H over h times square root of 9 plus h minus 3. Is there anything I can do now? You cancel out the h. The h is already factored in the denominator. You're not canceling into an addition or subtraction. You're not canceling into a binomial, so we can do that. That's now the limit as h approaches 0 of 1 over the square root of 9 plus h minus 3. Wait a minute, is it a, this should be a plus 3, my bad. There we go. Yeah, if it was minus 3, we'd be in trouble. Great. Miguel, any ideas as to what to do now?
No.
Let's go to Ethan's idea. What does Ethan always suggest we do?
Plug it in.
Plug it in. Does plugging it in work here? Yeah. And if a square root of 9, which is 3, 3 plus 3 is 6. So we end up with 1/6. That's it. So the big trick in this one was to multiply by the conjugate. So you're amassing a set of little tricks to do with these types of problems. How are we looking on that one? Got some more tricks for you. Don't worry about it. Let's keep going. So let's see. Let me give you yet another reminder. So one way to start this course is with a lot of review stuff, but I like to do the review kind of like right when you need it. In manufacturing, they call it just-in-time manufacturing, that you get the supplies just in time to make the car or whatever. Here, we're doing just-in-time review. So the review here is this. So reminder. A cubed plus b cubed and a cubed minus b cubed. So this is some factoring. And the factoring is, you know, something that you don't use often enough that you might not remember it. So let me help you out. In the first one, you've got the sum of two cubes. So my suggestion is you take and figure out, well, what do you cube to get the first term? That'd be an A. What do you cube to get the second term? That'd be a B. And we're going to take each of these terms to come up with the next couple terms. Likewise down here, you're going to have an A and a B. When you factor the sum of cubes or the difference of cubes, it's always going to be a binomial times a trinomial. So binomial times a trinomial. 2 terms and 3 terms. The second trinomial here, or this trinomial I should say, you can get by taking a times a, gives you an a squared, a b times b gives you a b squared, and I need to do something to get one more term. what else can I do? I'll multiply this by itself and I'll multiply this by itself. What else can I do to get that last term? A times B. Now, those are your terms. The last thing we need to figure out is how to fill in the signs in between these. And some of you might have heard of an acronym for this. What is it? No? You haven't taken me for algebra then. SOAP. Same sign, opposite sign, always positive. Try and fill in the signs for the bottom one. Same acronym, same sign, opposite sign, always positive. Joshua, what should I fill in here?
A negative between the A, B, a positive, and another positive.
Yeah. Something else I say about this is one negative sign per customer. If you look at the right-hand sides, they each have exactly one negative sign. Okay, so there's your not so subtle foreshadowing on this one. Let's actually look at the problem itself. So that's the limit as x approaches -2 of x plus 2 over x cubed plus 8. Ethan, I'm going to let Carissa steal your thunder here on this one. Carissa, what should we start out with? Try to plug in the limit. And when we do that, we end up with 0 over 0. Bummer. We're not going to get away with anything easy on this one. You got to do a little bit more work. Okay. Well, what work would that be? Any suggestions? All right. The 8 happens to be 2 cubed. All right, so that's a nice thing to notice. What does that allow us to do then?
Trying to cube to the polygon function.
Yeah, we're going to factor it. All right, so if you're watching this later, pause the video, see if you can't factor it using this formula up here, or just try it now. But give that a shot. See if you can't factor that. Tell me what you come up with. Who's got this? Obita. I don't think I picked on you. Wow. Go ahead. What do you got?
Okay,
Yeah.
X plus 2,
Mm-hmm.
x squared,
Mm-hmm.
minus 2x plus 4.
Perfect. Perfect. Thank you so much. That doesn't really change our situation too much. If you put in a -2, you get a 0 in the numerator. -2 plus 2 is still 0 times whatever is still 0 in the denominator. So it hasn't changed that part of the situation, but I do have something else I can do now. What is it? Nate, what can I do?
Cancel out that.
Yeah, let's get rid of the x plus 2's here. So that's going to leave behind the limit as x approaches -2 of 1 over x squared minus 2x plus 4. And, now what? Now what can I do? Plug it in, right? So the problem that we had is gone, because we're not gonna get 0 over 0 anymore, we're gonna get 1 over something. Negative 2 squared is 4, negative 2 times negative 2 is 4 again, plus 4 again. Sounds like 12 to me, 1 over 12. Now you can kind of confirm that by looking at a graph or a table. It's not as easy to look at the decimal values of that and go, oh yeah, 112. I mean, I don't think too many of you recognize 0.083333 very easily, but you can look in retrospect, say, calculate that and confirm that the limit is indeed 112. Okay. Let's take a look at one last one. Any other thoughts or comments on this one? All right. So the last one here will be this limit. Limit as h approaches 0 of 3 plus h to the negative first minus 3 to the negative first over h. So at this point, kind of no surprise, if you try plugging in h equals 0, you end up with 0 over 0. 0 over 0 is just the problem's way of telling you you've got more work to do. So let's remind ourselves what this notation means. What does it mean when I have, say, 3 to the negative first power? What's a different way I can write that? 1 over 3. So this is going to be 1 over 3 plus h minus 1 over 3 divided by h. And it's kind of unfortunate that we've got these fractions in the numerator. We've got two different fractions. So it'd be nice if I had a common denominator between these two. What is a common denominator between these two fractions?
9 plus 3h.
Okay, I'm going to keep it factored, but yeah, that works. So the LCD, let me write over here, LCD is 3 times 3 plus h. Okay. I want to get this numerator to have a common denominator for each of these terms, that way I can bring it together. So let's see what we can do here. That's going to be the limit as h approaches 0, 1 over 3 plus h, leave yourself some room, minus 1 over 3, again leave yourself some room, all over h. Now when I compare this term to this one, to get a common denominator, what am I missing from this that I have up here? Just the 3. So we'll multiply by, say, 3 over 3. 3 over 3. All right. What am I missing from this term that I have as part of my LCD? 3 plus h. So 3 plus h over 3 plus h. Okay. Great. Let's see what that gives me. That's going to be the limit as h approaches 0 of 3 over 3 plus h times 3 minus 3 plus h over 3 times 3 plus h, or write it backwards like that, over h. That doesn't look any better. Looks pretty ugly. Ashley's looking at that going, oh man, where's this going? Yeah, so good question. Well, why did I do that? I wanted to bring the numerators together and figure out what's going on with the numerators. And we can do that now because we have a common denominator. So let's keep our limits here. Limit as h approaches 0, If you stop writing the limits, then it's not really right anymore. So in the numerator, I'm gonna bring everything together over that common denominator. So 3 plus h, 3, so I'll have 3 minus 3 plus h, but I've made a mistake. Can anyone see the mistake that I made up here? And I did that because a lot of you might make that mistake and it'll cost you a point.
You have to distribute the negative sign.
Yeah, I gotta distribute that negative sign. So when you distribute that negative sign, instead of a positive h, you'll end up with a negative h. So let's finish this one out. We're almost done. Limit as h approaches 0. It's going to be 3 minus h over 3 plus h times h over h. And finally, Ashley, here's the answer to your question. Those 3's cancel each other out. And I'm getting real close now to what I need. Let's see. Something's bothering me about this.
The H should be a
H has to be
3.
3.
Say again?
The H and then.
Oh, that should be a 3, yeah. I was looking at, wait a minute. Yeah, there we go. 3. So we're left with the limit as h approaches 0 of negative h over 3 plus h times 3 over h. And that still looks like it's a problem. In fact, if you try to plug in h equals 0, you'd end up with 0 over 0 still. So let's do one more thing. I'm going to write that as h over 1 to make this last little step a little bit easier. You remember what happens when you divide things, divide fractions? You got to invert and multiply. So this is going to be negative h over 3 plus h times 3 times the reciprocal of this denominator. So the reciprocal is going to be 1 over h. Did that help me out?
Yeah.
H's cancel. And finally, after a good 10 minutes worth of work here, limit as h approaches 0 is going to be negative 1 over 3 plus h times 3. What's that limit going to be? Once you canceled out that h, now you can just plug in the limit. You get negative 1 over 3 times 3, which is 9. That is it. Whew. Don't worry, I'm pretty polite about these things on an exam. I usually put no more than 8 or 12 of them on an exam. All right. Any comments or thoughts on this last one here? Yes, Sailor.
This is just like a small thing about the point for like distributing the sign. Is there a certain way you want us to show that?
No, it doesn't matter. Yeah, as long as you distribute it, that's fine. You know, I wrote it out like this just to try and emphasize that you got to be careful about distributing the negative sign. But if you see that, and if you wrote 3 minus h right away, that's fine. I don't have to see every step on your paper that I'm showing you in mine. My goal when I teach this is to not lose anyone. I want you to be able to follow my steps. I understand that a lot of you are pretty smart and you've gotten to calculus. You wouldn't be here if you couldn't do some of this stuff in your head. I don't expect to see every little step. So if you're not showing me every step, as long as the steps that you're taking, the jumps that you're taking from one place to the next, don't exceed what I can take, then you'll probably be okay. All right? All right, anything else? Let's take a break.